Hi everyone, I'm really excited to interview Chang. He's currently working as deep learning research scientist at Autodesk Research. He did his bachelor's in physics and mechanical engineering at National Taiwan University and pursued his master's in science in robotics from Carnegie Mellon University. In this episode, we'll discuss about various applications of AI in industry and also talk about his research papers published recently. So without much ado, I'll start the interview. So Mr. Kai, can you tell us about your background?
Yeah, so I'm a research scientist in Autodesk Research. Right now I'm in a team. It's called AEC Industry Future Team. So what AEC stands for is Architecture, Engineering, and Construction. So basically, right now I'm mostly researching on like deep learning opportunities in this AEC architecture and construction domain. So my background is kind of multidisciplinary. So I started my undergrad mechanical engineering, but later I switched major to physics because I love astrophysics. But later on, I feel like astrophysics is like very like abstract. So I'm a more hands-on person. So I minor back to mechanical engineering. And then that's when I found my interest in robotics. So I actually love building stuff. And yeah, so I applied to CMU Robotics Institute, the master program. So yeah, that's where I learned robotics and also some of the latest deep learning technology. And I'm very happy that I got this chance of applying this deep learning technique into architecture and construction. So basically, I'm pretty open to learn new stuff, and I like to, try out a bunch of new things in seeking opportunities in different domains.
That's quite interesting how you worked in different disciplines and eventually found your interest and passion. So my next question is, what inspired you to become a deep learning research scientist?
Yeah, so basically, my personality, I tend to like building cool and mind-blowing demos. So I like to test out what people have never tried before. So when I'm choosing my, major or my research passion, I tend to think about, okay, what topic is has the most potential, right? And deep learning is definitely one of the most popular science that nowadays. And also, yeah, so I also see a lot of potential application that can be applied.
Mhm. And how does a day in your life look like?
Yeah, so during my work days, you know, as a researcher, I definitely need to learn. So I not only read papers, I also learning from domain experts and also some of our customers because I'm not coming from the background of architecture or construction. So I got to like learning by interviewing and get to know their workflows and yeah, so other than learning, it will be basically working, like implementing stuff. So doing research, for deep learning research, there are multiple phases. So like data generation, data collection, cleaning, and then training the model and eventually evaluating the results.
Mhm.
Yeah, so that's basically my what my day looks like.
I see. And any mentors, guide, or role model who made a significant contribution in your life?
Yeah, I would give this honor to my master mentor, Professor Stelian Chorus. Yeah, so yeah, he taught me a lot of things, and yeah, so he has done a lot of research in computational design, and his research work is are all very like creative and inspiring. So it kind of match my personal interest of building cool stuff, and he not only did he like showed interesting work, he also taught me like the importance of having a like technically grounded solution instead of like randomly trying out a bunch of stuff. And yeah, so I basically would like to thank him and learn a lot from him.
Mhm. Uh, so now we will move on to our next section, which in which Kai will talk about his professional work. How was your research experience at Carnegie Mellon University?
Yeah, so I had a very interesting research project. So it's all about like soft robots, and I started this project with physics-based simulation. So it's this topic actually coming from computational design and uses some of the computer graphics simulation techniques. So if you know about like finite element analysis, I learned that from my mechanical engineering major, and then I actually built this physics-based simulation tool to help designing the soft robots. So one paper I published on SIGGRAPH 2017 is interactive design of animated plushies. So if you know like plush toy, I basically routed cables on some of the bodies in a plush toy, and then our system can basically do kind of inverse design. We want some motions, and where should we put the cables basically, so that when we pull the cables, it's like puppetry. When we pull the cables, the plush toy will do our desired motion. Yeah. So after that, an idea came to my mind is actually, instead of having this plush toy, we can actually build a foam hand, right? We cast a foam robot out of a human hand, right? And then we can have this very dexterity given the complex shape of a human hand. And then, yeah, so we build this foam hand, and I do like 3D scanning to build a virtual model and then throw that into my simulation environment. And then I try to learn the control. Yeah. So yeah, it's a very interesting topic, and actually like never had most of most of the soft robots in a research community are basically like regular shape. So I kind of push the boundary to do research on a more complex shape or arbitrary shape for the soft robot. So I think it's a very interesting and inspiring research work. Yeah, so that's basically my research in CMU.
Yeah, that sounds quite interesting. I'll definitely share the link of those videos in the description. Can you tell us about your work experience at Autodesk?
Yeah, sure. So recently we published two papers, and I would like to share these two papers in this talk. So the first paper is called House-GAN. This is a intern work, and we also work with Professor Yasu from Simon Fraser University. So this paper is submitted to ECCV this year, and we're still waiting for author notification. Yeah, and this work is basically trying to solve a problem where when architects are brainstorming kind of room layout designs with their customers, architects usually start with this bubble diagram, right? And then they have to go back and forth discussing with their customers what are their needs, like this bubble diagram, if it makes sense to satisfy their functionality. And then architects will go back and then come up with this layouts, right? And then customer will look at the layout and point out some of the things they do not like as much, and then architect has to go back. Right. So we want to automate this process, right? We want to have this process of generating multiple layouts that satisfy this bubble diagram, so that this is kind of a tool where we can generate a bunch of solutions. So even with this one, the same bubble diagram, we can create a bunch of different layouts that satisfy this bubble diagram, right? And then maybe the customer can choose from one of this and then do some tweaking. Yeah, so this is basically this research. And yeah, and another paper is learning to simulate and design for structural engineering. This paper recently got accepted to ICML 2020. So this work is actually, I think it's the first paper that applies like deep graph neural networks on structural engineering. So we model this building geometry with a structural graph, and then we want to train an optimization model for this site design. So site design is basically, we have this building geometry, the skeleton of the building, right? And we want to output what are cross-section types for each bars, like columns or beams, right? And yeah, and the optimization involves some of the structural analysis outputs, right? We want to make sure that this size design satisfies some like building code constraints, for example, like storage drift ratio, limit, etc. So we also want to train a surrogate model for structural analysis. Here's the simulation, structural analysis. And we can have this trained model to output predictive structural analysis results, and then we can compute our objectives and constraints. So this is an end-to-end learning pipeline. So we can first pre-train this surrogate model, and then we train the optimization model. Yeah. So some of our, yeah, I can show this our generated designs, so which is very interesting. Yes, so we, we train the optimization model for different scenarios, and then we can have this here. The harsh constraint is we have a very strict drift ratio limit, while the moderate constraint is we have a higher, which is looser drift ratio limit. And we here the zero weight and low weight and high weight are the cost, the weight of the cost loss. Yeah. So yeah, we can see that some of when cost is not in our consideration, we get really like complex design. And yeah, and but if we add the cost objective, increase the weight of cost objective, and we get like better designs. So if we take a look at the the high weight solution, right? For moderate constraints, we can see that the model generates these, it has these micro decisions on individual bars, which doesn't look natural to human designs. But for the harsh constraint, we see that this looks more like a human design, right? So we actually show this design to structural engineers to get their feedback, and they do see some of these insights. So for example, we see the model tends to use stronger and thicker columns at the bottom of the building, which we didn't specify it during learning, right? The model actually learns because of the objective we give. Yes. So this is the result for optimization model. Our surrogate model also performs pretty well. So we reach a 98% accuracy, and compared to, we use Autodesk robot structural analysis for the structural analysis software, and compared to that software, yeah, our model is like very fast. Yeah, it's 300 times faster. So our model only takes like 43 milliseconds. Yeah. So what what can we get from these two trained models? So for surrogate model, right, we have a fast approximation of the structural analysis, and this can be used to provide instant feedback for example, like architects when they're in like early design phase, right? We can already have this plugin instead of having a structural engineer or structural analysis software at the site, and which is very slow and laborious. And also, when we're doing some kind of simulation-based optimization, we have in each iteration we need to call the structural analysis software, right, which is very time-consuming. So we can actually use this surrogate model to replace the traditional software. And for the optimization model, we later show its performance comparing to genetic algorithm. So the solution can actually serve as a seed for genetic algorithm, and that actually speeds up the optimization process like 8 times. So yeah, so I think this is a very interesting research work, and this is actually the first paper that applies graph neural network to structural engineering domain. And I do see there's a need to raise this interest from deep learning community, and then they can jump in and create more interesting research work on this direction.
That's quite amazing. What kind of exception rule can we apply when we are doing this analysis? So if I have a preference for certain types of sections, can
Yes,
we do
yes,
that?
yes. So in the optimization, yeah, we consider different objectives and constraints. And yeah, one assumption I made here is that these objectives and constraints has to be differentiable because of the back propagation nature of neural networks. So here our cost objective is basically, yeah, you can have a cost model where you have unit cost for every single bar. You can just compute the tonnage, right? You have the length, you have the cross-section area, you have the density, and then you can multiply by the material cost, right? This is definitely differentiable, right? This is like, yeah. And drift ratio constraints is also, you can just penalize when there's drift ratio larger than some limit. Here we also have this variety constraint because we learn from our customers that, when we have too many different kinds of cross sections, the manufacturer cost tends to increase. So here I set the limit to 6. So, again, we just limit the different numbers of cross sections. Here I did some design of the this constraint function so that it makes sense. It's differentiable and it also provides a good gradient. Yeah, so this is still some assumption of this limitation of this method. There are still other techniques that can deal with non-differentiable methods such as using reinforcement learning, but this is a different technique other from this paper.
Mhm. And the long-term vision for this tool is this can be really helpful in the conceptual design phase for architects to do the sizing without getting dependent on other engineers to do that.
Yeah. So yeah, other than that, structural engineers can, instead of starting the design with like starting the design from scratch, right? We can have propose an initial design, right? Saying like, this is the design, and what the structural engineer thinks about this, and then they can do like kind of grouping and group editing, and to yeah, or maybe if the model generates something, right? And the structural engineer thinks like this is suspicious, he can actually test it, and if he sees the value of the results, then maybe the model becomes like generating inspiring solutions, right? This is also something that is very interesting.
I see. And going back to your first paper, how do you determine the relationships between different types of programs?
Yeah, so since this is the first paper that investigate this graph to layout work, so we do not consider very complex bubble diagrams. So here the connectivity are mainly based on if the two layouts are next to each other. Yes. So I know there are other different type of edges. For example, like if you think about coming from the main entrance, right, and you want the main bedroom to be more inside the room, right, because it's more private, right? Sometimes bubble diagram has to deal with that. And here we also do not deal with the door, right? You can imagine there should be some door connectivity. Yeah, that will makes the diagram has more information. Yeah, but since this is the first work, we just deal with their connectivity if they are next to each other.
I see. So the vision for this is getting as many different layouts with this combination as much as possible and then figure out like the circulation and the detailed program layout.
Yes. Basically generating a variety of layouts that satisfy this graph constraint.
Okay. And right now it's in 2D. So if we have a building with several programs in third dimension.
Yeah, that's actually uh, part of our future work. So you can imagine that 3D, right? We can extend this. Right now it's 2D bounding boxes, right? We can extend it to 3D bounding boxes. right? But then we kind of get into a challenge of how we're going to represent this 3D bubble diagram. Yeah, so that's actually a very interesting future work, and definitely, yeah, we're actually working in this direction.
All right. This is quite interesting. Thanks a lot for sharing.
Sure.
Now, my next question is, how do you envision applications of AI in building industry in next 5 years?
Yeah, so I believe a lot of, yeah, since I'm not coming from the architectural construction background, I basically learn like what are some of the ideas out there, and also learn some of the pain points, and thinking about how AI and deep learning can help solving these problems. So there are different aspects. So there's one thing that is definitely assistive design tools, right? So we basically build design tools to not replacing the human design work, but replacing the boring and mundane part of the task, right? So such as like tracing, I, what I heard is that a lot of junior architects, they join the company and they start with these boring tasks instead of doing some of these creative work. And also, what AI can do is that they provide informations, right? Instead of providing some decisions, because like design and architecture design and also structural design, this is very complex decisions, right? So instead of expecting our model to give 100% accuracy result, we tend to think about how AI can provide useful information to aid the human to make the decisions. Yeah, there are other things like training the creativity. This I think is a much futuristic work. So right now there are AI and deep learning models that suggest like fashion wears, right? So this is kind of creativity. There's no like true or false, right or wrong on the decisions, but it's more like aesthetic sense of different things. So maybe someday, like in the future, AI can have show some creativity.
Mhm.
And yeah, there are other things like right now, I also see a need of integrating the architecture design and construction, right? Because if they are not connected, then we might suffer from a, a huge cost in decision changes and a lot of communication that needs to happen going back and forth, and also time cost that we put in because of this problem, right? So yeah, one kind of solution is that we bring the late like construction phase, some of these informations and decisions early in the design phase, right? So we can deal with solve these potential challenges or problems early in the design phase. Yeah, and others are things are like faster, like automation of some process. But a more interesting kind of way to build a model is we can make it more interactive, right? So it's not like automating, replacing human work. We make it more interactive. Yeah. Yeah, and another direction in AI and deep learning is we're trying to build a more explainable AI. So instead of generating some solutions, we want the model to actually reason like why this is the solution, and maybe show some explanation to the user why it's making this decision. So I think that in recent years there are a ton of work that is researching on reasoning skills. So this is especially critical to complex domains such as construction, right? So think about like images. We are just asking the AI model to look at the image, and so it's basically like perception, right? While if you're doing like a construction, you base or structure design, you have tons of building codes you have to satisfy, right? So and like some decisions you made in this part of the building might affect other parts. So there's this causal relationship you have to understand. So I think this is yeah, a bigger challenge for the AI.
Interesting. According to you, what are the potential challenges faced by building industry to adopt AI applications?
Yeah, right now in Autodesk, we deal with a bunch of customers, and there are a lot of challenges we face when we're trying to collaborate with industries, because not, it is, I think it is still a very, not many industry has, adopted this AI application, right? I know it's because, changing the same workflow that exists for decades is very hard, right? And you have to invest a lot of money and time, for example, like collecting data. So one issue is that most of the time we don't have enough data, right? So imagine a company who has run for 10 years, and each year they provide 50 projects, right? Either design or construction projects, right? They have basically 500, but 500 is usually not enough for training deep learning models. So usually we'll have uh, 10K or 100K data. So yeah, this is the challenge there. So it is very hard for one company to get enough data. So we kind of have to have different data collection strategies. But I also think that there's a need that the industry or academy can start making these public data sets, so that makes an easier access for deep learning researchers to actually build applications around this domain. So I want to give this example of, yeah, recently there's AI drug discovery that just appears in recent 2 years. So it's also using graph neural networks, and chemistry and biologists, they build this chemical data sets. And now there's a bunch of these innovative research just because they have this public data set, so that deep learning researchers can use it and build solutions around that. So MIT actually used deep learning to find an antibiotic called halicine. So if we can have a similar data set like for architecture and even for construction, then I believe that we can make a much faster progress in this domain.
Now, we will move to our last section, which is about advice to students and professionals. So, what will be your advice to people who wish to do similar work?
Yeah, so basically I see there are two different types of work. So one is more on the research side, and the other is more on the product side, right? Product side, they care more about low hanging fruits. They want to build a working prototype, right, instead of a limited prototype. So for people who wants to, who's more interested in low hanging fruits, I would recommend learning some of these image related deep learning techniques, because those are more mature. And as many of you have already uh, learned the power of computer vision, right? We have this Facebook filters, and we have this detection model for traffic lights in self-driving cars, right? We can do similar things for detecting different symbols in drawings, right? That's one example. Yeah, and also there might be you might also want to take a look at some of these active learning, because you might want to have a model that keeps learning over time, because at the beginning you don't have enough data, right? So when the user generates data on the fly when using it, right, how can the model update itself to gain better performance? And for the research side, recently, yeah, you can take a look at harder problems and other techniques such as reinforcement learning, right? Because some of these, some of the objectives or constraints is not differentiable. So you might want to use reinforcement learning to train a model, right? And also graph neural networks is very popular. It can deal with these relational information. Yeah, so a lot of these can yield, yeah, these relational inductive bias, so it's basically learning the relation, can actually help the reasoning for the neural network. So I also some non-deep learning paper, including knowledge. right? And how you can encode like rules, right? Either human rules, human design rules, or building codes constraints, right? I think this is closer to the nature of like construction and structural engineering industry. Yeah, so overall, just find interesting problems and think about like interesting interactions, and also ask yourself like why you want to build this model. Is it just because, oh, I have a tool and I have a hammer and I'm seeking a nail, right? But yeah, or yeah, I would recommend thinking like how you can build this tool that actually solve the problem.
Yeah, I
Yeah.
think that's a really good piece of advice. And can you share some resources which will be useful to people who are interested to learn about AI and its application in building industry?
Yeah, to be honest, there's not much, application. Well, I'm a AI researcher, right? So I most of my focus is in the AI community. So I don't see a lot of like AI applications in this industry. But I would recommend, if people wants to learn more or get inspirations, I would recommend people to read different AI papers that is applied in different other domains. So for example, I got inspired, because I see graph neural networks used in chemistry. I also see that, oh, can be applied in building structures too. Right? I think, yeah, so most of the AI papers are publicly available at archive, and there are also some like well-known conferences I recommend everyone should attend, is like ICML and NIPS. And there are other specific conference image related conferences like ECCV and CVPR, right? So if you want to deal with like design drawings, then definitely these are some of the conference you would like to attend.
Mhm. And how can students and professionals use AI in their design?
Yeah, currently there are not many like tools or packages released, like, just plug and play kind of tools. At least I don't know a lot of them. So it is very likely that you have to like build one. So I imagine that if you read a paper and you think about some of these applications in in the in the architecture or construction, right? You might want to look at, do they release some GitHub codes that you can like make some changes and then to satisfy your application. Yeah. There are also, yeah, or another way is you just work with people with computer science background, right? That's also one solution. And yeah, because you can provide these your professional background and also work with computer science, how they're going to design the solution, right? And also you have the knowledge of creating your own data set, because it is very hard for us, for deep learning researchers, to actually know everything about the industry, right? So it is better for um, people with professional knowledge to create the data set and also have a source of, consulting. So yeah, so that's the way of working with people with deep learning background.
How can our listeners follow you and your work?
Yeah, people can add me LinkedIn, or if you have any questions, welcome to send me an email.
All right. Thanks a lot, Kai.
Yeah, I also want to thank you. You built this very meaningful channel. I believe a lot of people have learned a lot from the videos you share. And if I have further, updates on my new research, I'll definitely let you know and share it to everyone.